Now we are going to solve indefinite integrals, some more indefinite integrals, likely to be board standard, any type of boards in India, say as CBSE board, West Bengal board, ISC board, any board in India. Now we are going to solve today some indefinite integrals by using by parts. Integration by parts. First time we are going to solve some integration is the product of two functions. That is, say if u and v are differentiable functions of x, differentiable functions of x, then we can write integration u into v dx. That is, u is a function of x and v is a function of x. That is u into v. First time we are coming to solve by product of two functions, differentiable functions of x. This is the property. We say it is a first function, v is the second function, u is the first function, v is the second function. This is the rule. We have to solve this u integration v dx minus ddx of first function, that is u, integration second function whole dx. This is the rule. We uses the rule. We solve here some by parts problem. This is the rule. Consider u as a first function and v as the second function. Now, usually we have taken what part we have to take first function and which function we have to take second part. Usually we go a rule, I-let rule. We called it I-let rule. That is, I is trigonometric inverse function, A is the logarithm, A is remaining algebraic function, T is trigonometry function, and E is exponential function, that is e to the power x or a to the power x, so on. We can, whichever is left of the other function, left function we have taken as u function, that is first function. If we consider a problem, say integration x into log x dx, here logarithm is left of algebra. So we have to take log as a u function and this algebraic function as a v. Whichever is left we have to take usually, not necessarily for all time, but usually we take the left function which is just left of the other function. That is, here in this problem example x log x, we consider x as a algebraic function and log x is logarithmic function. Here in I-let, L is before of a, that is algebra. So take log x as u function and x algebraic function as v function. If we take another, that is x e to the power x, see here exponent function, this is algebraic function. Algebra is before exponential function. So in that case we take algebraic function as u and e to the power x as v function. Okay. Now this can be proof also. How to prove? This is I-let rule. let u and w are two functions, two differentiable functions of x. So ddx of u into v, we can write u into dv dx plus ddx of u into w. So it is w du dx, multiplication rule of differentiation, and u dw dx. Okay, we considered as u and w are two differentiable functions of x. So ddx of u into w is w into du dx plus u into dw dx. Now integrating both sides with respect to x, we get u into w equal to w into integration w into du dx into dx plus integration u into dw dx into dx. Okay, integrate both sides, we get that. Now consider dw dx is v, dw dx is v. So dw dx, yes, so w is integration v dx. Now here we substitute here in place of u into w means integration v dx equal to w is here integration du dx into w means integration v dx whole dx, and this u and dw dx is v, dw dx is v. So we got integration, so we got here, we got here from here we can write integration u into v dx equal to u integration v dx minus integration ddx of u, and that is du dx integration v dx whole dx. That is that. Okay, integration u into v dx, that is integration u into v dx and ddx of u into integration v dx. This way we can prove that rule. So this is the rule to solve integration by parts. Now we are going to solve some problems. Again we repeat, integration u into v dx is u, considering u as a first function, v as a second function, integration u into integration v dx minus integration ddx of first function integration second function whole dx. Now how to prove? Let u and v are differentiable functions of x. So ddx of u into v is by multiplication rule of differentiation w into du dx plus u into dw dx, integrating both sides. Now putting dw dx is v, so dw integrating both sides, w is equal to integration v, just replaces it we get these properties. Now we are going to solve some problems. Okay? Now we are going to solve some problem. Just we have to remind in that things. We have to remind it. Then we can solve all type of by parts problem. In my first episode, I wrote all the formulas of integration, but again we write three formulas which is directly used is root over x square plus a square dx is x by 2 root over x square plus a square plus a square by 2 log x plus root over x square plus a square plus constant. This is one formula. Number 2, integration root over x square minus a square dx is x by 2 root over x square minus a square by 2 log x plus root over x square minus a square plus c. And number 3 formula, integration root over a square minus x square dx x by 2 root over a square minus x square plus a square by 2 sine inverse x by a plus c. These 3 formulas we have to use to solve some by-part problem. And now we are going to start the problem. The first problem is, my first problem is a simple problem. Number 1, integration log x dx. We write the rules of integration u into v dx. Here u integration v dx minus integration ddx of u into v dx whole dx, and using usually I-let rule. Now here log x, we have to integrate log x. Looks like it is a just one variable, one differential variable. Sorry, it looks like a one function, but we have to use here u into v method. So we take 1 into log x. Now considering as a logarithm function, and this is as 1 as algebraic function. Considering log x is logarithmic function and algebra 1 is algebraic function. Here logarithm function is left of algebraic function. Logarithm function is left of algebraic function. So we have to put this is u and this is as v. We have to put log x base e as u function, since logarithmic function is left of algebraic function. So logarithmic function is taken as first function, that is u, and algebraic function is taken as v function. Now using this rule, u integration v dx, that is log x integration 1 dx minus ddx of first function, that is log x, integration second function, that is 1 whole dx. Now integration of 1 is x, ddx of log x is 1 by x, integration dx is x whole dx. This is the rule. Now it becomes x log x minus x cancel, that is only integration dx. So x log x, integration dx is x plus c. This is our answer. So integration of log x, it looks like a single function, but actually we multiplied this function as 1, taken log x as a u function and 1 as a v function by using highlight rule. Since logarithm is left of algebra, so we take log x as the first function. Now applying this rule, using this rule, we get the answer. Now next problem, we are going to solve the next problem. Integration sine inverse x. It also looks like a single function, but actually we can write it sine inverse x into 1 dx. Again, inverse function is left of algebraic function. So considering this is as u, this is as v. Okay. So now using the rule u into v method, sine inverse x integration dx minus integration ddx of sine inverse x integration dx whole dx. This is the rule u into v method. Now integration dx is x and ddx of sine inverse x, we have root over 1 minus x square. ddx of sine inverse x and integration dx is x. Now you have to solve this integration. How to solve? We can take it from here 1 minus x square as z square. Going to solve by method of substitution, this part. We are taking 1 minus x square is z square. So minus 2x dx is 2z dz or x dx equal to minus z dz. Now put it here. X dx is minus z dz by root over z square. So root over z square is only z. So z cancel, it becomes only dz. In the next line, here root over z square is only z, z cancel, only dz. That is x sine inverse x plus z plus c. So x sine inverse x, z is root over 1 minus x square plus c is our answer. This is my second problem. Now we are going to solve another problem. Problem number 3. Solve another problem, that is problem number 3. Problem number 3 is x sine inverse x. Using highlight rule, algebra is left of inverse function is left of algebra. Inverse function is left of algebra. So we have to take inverse function as u function, and this is as v function. It is, since inverse, trigonometric inverse function is left of algebra, so we take sine inverse x as a first function and x as a v function, that is second function. Now using the rule u into v, sine inverse x integration x dx minus ddx of sine inverse x integration x dx whole dx. Now integration x is x square by 2 sine inverse x. Here, dx of sine inverse x is 1 by root over 1 minus x square, and integration x dx is x square by 2. X dx is x square by 2 dx. Now how to solve this? Again we can put x equal to sine theta, you can solve it by method of substitution. We are going to solve in some slightly different way. This 1 minus x square we can write 1 minus x square by root over 1 minus x square. Now separate it. 1 by root over 1 minus x square dx, and minus minus plus half 1 minus x square by root over 1 minus x square is root over 1 minus x square only. Just separate it. 1 by this and this by this. Now we have problem, direct formula, just like before this formula, and this is the integration. Integration of dx by root over 1 minus x square is sine inverse x. Now just putting the value, sine inverse x minus half sine inverse x, and this is x by 2 root over 1 minus x square plus a square by 2 sine inverse x by a plus c. Now rewrite, just taking common, we get x square by 2 minus half plus 1 by 4 sine inverse x plus 1 by 4 x root over 1 minus x square plus c. Next, just adding it, we can get by adding it we can write this x square by 2 minus 1 by 4 into sine inverse x plus 1 by 4 x root over 1 minus x square plus c is the answer. Okay, this is my answer. Next, going to solve the next problem. If you like my channel, please subscribe and share. Please subscribe and share. And anyone, any problem on these types of sums, call me on phone number 9830495093. Sorry, 9 again repeat, 9830495093. This phone number we can phone me. Okay, any problem, any doubt, you can phone me, and that number 9830495093. Now we are going to solve another problem. This is my fourth problem of today. Okay, so if you like, please subscribe my channel and share it. Anyone, any problem, can call me on that number. Okay? Problem number 4. Problem number 4, that is x sine inverse x by root over 1 minus x square dx. This is problem number 4. We can put here x equal to sine theta or sine inverse x is z. Anyone. Either x equal to sine theta or sin inverse x is z. Putting sin inverse x is z. Z is sin inverse x. So dz is 1 by root over 1 minus x square dx. Differentiation of sin inverse x is 1 by root over 1 minus x square. From this we can write x equal to sin z. So now replace here. Putting this x equal to sin z and sin inverse x is z. Putting sin inverse x as z and sin inverse x is z and x is sin z and dx by root over 1 minus x square, that is dx by root over 1 minus x square is only dz. Now using by parts, simply this becomes trigonometric functions and this becomes algebraic function. Now if we apply the Eilert rule, algebraic function is left of trigonometric function. So we consider z as a u function and sin z is a v function. Since algebra is left of trigonometry, so here z is the u function, that is first function, and sin z is the second function, that is v function. Now applying the rule of integration u into v, z integration sin z dz minus d dz of z integration sin z dz whole dz. So integration of sin z is minus cos z, differentiation of z is 1, integration sin z is minus cos, that's why we put minus minus plus here, cos z dz. Now integration of cos z is sin z plus c is our answer. Here we put z equal to sin inverse x, that is x equal to sin z, and from here if we find cos z becomes root over 1 minus x square, because we know that sin square z plus cos square z is 1. From that we can write cos z is root over 1 minus x square. Now replacing cos z is root over 1 minus x square, cos z is root over 1 minus x square into z. Z means sin inverse x and sin z is x plus c. This is our answer. Okay, this is our answer. Very simple problem. Just putting z equal to sin inverse x, or we can put x equal to sin theta. My next problem, that is my last problem of that episode. We are going to solve another more problem on the next episode. So this is my last problem of that episode, number 5, question number 5, integration x plus sin x by 1 plus cos x dx. This is my last problem of this episode number 9. If you like my channel, please follow me, please subscribe my channel and share. Anyone, any problem about any sums, you can phone me on that number 9830495093. Now firstly we separate this. x by 1 plus cos x dx plus sin x by 1 plus cos x dx. Now using some multiple angle formula, 1 plus cos x is 2 cos square x by 2 and sin x is 2 sin x by 2 cos x by 2 and 1 plus cos x is 2 cos square x by 2 dx. Cos square, 1 by cos square is sec square, and here 1 cos x by 2, 1 cos x by 2 cancel, 2 cancel, it becomes only tan x by 2 dx. Now this is special type problem. Just integrate the first part using by parts. This part will be cancelled. Okay. Now we start the differentiation, integration u into v function, taking this as v function and x is algebraic is u function. So x using u into v rule, sec square x by 2 dx minus integration ddx of x sec square x by 2 dx whole dx complete plus this tan x by 2 dx. Now sec square x by 2, integration of sec square x by 2 is 2 tan x by 2 minus ddx of x is 1, sec square x by 2 is 2 tan x by 2 dx plus integration tan x by 2 dx. Now just multiply, 2 cancel, x tan x by 2 minus integration this 2 cancel, tan x by 2 dx plus this tan x by 2 dx. Now this cancelled. Only x tan x by 2 is the answer. So x tan x by 2 plus c is our answer. So this is the first part of integration by parts. We are going to solve many more problems in the next part. So thank you for all. If you like my channel, please subscribe, and if you phone me any problem, any doubt about the problems, thank you for the time.